So our last piece that we're going to cover in section 2.1 of these polynomial functions is another quadratic application problem, and it's with a parabolic application, vertical free fall motion. We're going to be given two formulas, s of t equals -1/2 gt squared plus v sub o t plus s sub o, where height is going to be represented using s and vertical velocity is going to be represented using v. T is going to be our time in seconds, so this is going to be our height in terms of some time, and this is going to be a vertical velocity in terms of time as well. G is represented using 32 feet per second squared or 9.8 meters per second squared, depending upon the notation that is used in the problem that you're looking at. And the G is our acceleration due to gravity, and that is a standard measurement that will not change. And v sub o is the initial vertical velocity, and s sub o is its initial height. And just note that anything that you have written with a little sub-zero always means initial. It means the beginning. It means the starting point. So always take note, no matter what class you're in, that this little notation just means that's the beginning. So when the ball is being thrown or the rocket is being launched, if it's given an initial velocity, it's the beginning. It's the starting height. Where was the ball thrown from? How high was the catapult off the ground when it was launched? That is the starting height, and that is how that is represented. So here we have an example. As a promotion for Wrigley Field, a competition is held to see who can throw a baseball the highest from the front row of the upper deck of seats, which is 83 feet above the field. The winner throws the ball with an initial vertical velocity of 92 feet per second, and it lands in the infield. So I see this feet per second notation, and so I know that means I'm going to be using my 32. So the first thing I want to do is find an equation to model this situation. So we're given the equation of height in terms of time. So I will start out with s of t equals, which is my height in reference to some time. So I'm going to have -1/2 g, which was going to be 32 because it's in terms of feet per second. And t squared is my unknown, hence the t, plus my initial velocity is given at 92 feet per second, but I just represent that with 92, and my t is unknown. And then my initial height is the person that is throwing the ball is 83 feet above the field. So that is my initial equation that I'm going to use to model this situation. I'm just going to simplify it a bit by taking -1/2 times 32. So I get -16t squared plus that initial velocity times time, and then my initial height. So that would be my A. This is going to be very tight here, so I apologize for that. Then we go to B. What is the maximum height of the baseball? And actually, I will use this to make it a little bit easier for you. So we have maximum height. We know that when we're looking at maximum height, we are actually looking for the vertex. And when I'm solving for maximum height and for the vertex, I use the equation opposite of B over 2 times A. And so here I have opposite of B over 2 times A, and then substituting in the values that I know, I have -92, which is my B, taking the opposite of it, over 2 times A, which is -16. So on your calculator, you take -2 divided by 2 times 16, that's in parentheses, and you should get 2.88 seconds. And this is the time it takes to reach maximum height, because you have your x value, this is in terms of time, and your y value is in terms of height. So when I'm solving for x, I'm actually looking for the time that it takes to reach that height. So I'm looking for this time. Then it's actually asking you for the maximum height. So now I need to find the y value. So I'm going to take my x value and plug it back into the time. There's the t. I'm going to plug it back in for the time and solve for my height. So I get y equals negative 16, excuse me, 2.88 squared, quantity squared, plus 92 times 2.88 plus 83. And you get to type that directly into your calculator, and you find that to be 215.25 feet. And that is your maximum height. And I do have a little graph here to draw that out. So standing at 83 feet, so it took 2.88 seconds to reach 215.25 feet. C asks, how long is the ball in the air? So if I want to know how long the ball is in the air, that means that the ball in the air starts here, travels up, and then comes back down and lands here. So it stops traveling when it lands on the ground. And so if it's landing on the ground, I want to know this time to this time. I'm actually going to need the quadratic formula for that. That is what I use to find the zeros. So I take opposite of b plus or minus square root b squared minus 4ac all over 2a, pulling all my values from my original equation that I wrote at the top. And I find out that the discriminant, 92 squared minus 4 times a times c, is 13,776. Typing that into my calculator, I type in negative 92 plus the square root of 13,776 divided by negative 32. And I get a time of negative 0.79 or 6.54 seconds. Obviously, I'm not going to have the negative time, so it will take 6.54 seconds in order for that ball to land on the ground. And I drew this out so that you can see, because this does not start at 0, that if I would continue the parabola on, it would, in effect, have a negative value with it. And that's where the negative 0.79. But we can't measure that, and that is the wrong distance, so we use the 6.54 seconds. Then the last question asks, what is the vertical velocity when it hits the ground? So that means, so we had the initial velocity when it started, but when it actually lands, how fast is the ball going? And that's where we can use our second equation that was given, velocity equals negative gt plus the initial velocity. So I substitute in the negative 32 for g, and then my time is the time it took to hit the ground. So it would be this time here, 6.54 that I just found, plus 92, and that is the initial velocity. You type that into your calculator, and you should get negative 117.28 feet per second. And it is okay to have a negative value here on the velocity as we have a downward motion of the object. And so as the object is going up, it would be a positive velocity, but then as it changes direction and goes downward, we do have it represented using a negative. So that is appropriate for that to have a negative 117.28 feet per second.